Today we want to tackle a problem like this, where we're finding the partial fraction decomposition for 5x squared minus x plus 27 over x cubed plus 9x. So remember that the goal is to take this big messy fraction, or this big fraction, and break it down into two or more smaller fractions and have equivalent ones so that if we would graph them, they would be the same. So what's the first step of finding a partial fraction? You guys should have it on your notes from yesterday. Good. We need to take an a, right, over an x. Why a over x? What's our very first step? Yep, we have a greatest common factor. We're going to factor our denominator. That's always our first step. Okay? So we have x in common. We take it out. We get x squared plus 9. Okay? So we need an a over the x plus what over the x squared plus 9? Good. Because this is quadratic, we need a bx plus c, something linear on top. Okay? Then the idea is to multiply by that denominator, the big fractions denominator. So when we do that, we get plain old 5x squared minus x plus 27. And when this gets multiplied by the common denominator, the x's go away. So a has to be multiplied by the x squared plus 9. And when this one gets multiplied by that common denominator, the x squared plus 9's go away, so x is being multiplied by the bx plus c. Okay? Now, normally, we would say, what are good numbers to plug in for x, right? And we can still do that. We can say, let's let x be 0, right? But it's not going to help us completely because we have a messy thing here, right? An x squared plus 9, there's no good number, real number, to plug in for that, okay? So when you notice that you aren't going to have real simple, nice, good numbers to plug in, what you can do is you can multiply this out, FOIL it out, or distribute it out. So we'll have an ax squared plus 9a, make that capital, plus bx squared plus cx. Okay? Now, gather your like terms. I have an ax squared and a bx squared. So we're going to take the x squared out, and I'll have an a plus b. I took the GCF of those two terms. Okay? Now I see, if I'm writing this in descending powers of x, a cx, and I see the 9a, which has no x. It's our constant. The good thing about this is if that's equal to our 5x squared minus x plus 27, then the coefficient of the x squared has to be equal to the coefficient of the x squared. So 5 has to be equal to a plus b. The coefficient of the x has to be equal to the coefficient of the x. So -1 has to be equal to c. And the coefficient, or the constant, has to be equal to the constant. So 27 has to equal 9a. So a has to be 3. And now that we know that a is 3, 3 plus what gets me 5? So b is 2. Okay? All that's left to do is rewrite our decomposition as the 5x squared minus x plus 27 over x cubed plus 9x will be equal to a over x plus b x plus c, and write a c there, over the x squared plus 9. Because that was quadratic, we couldn't just find easy numbers to plug in. So it helped to FOIL it out this time. And then recognize that anything in front of the x squared has to be equal to anything in front of the x squared. Anything in front of the x has to be the coefficient of x, and the constant has to be the constant. Okay, what questions do you have about this slide? Feel okay? Different method, because we're doing the same thing, but we couldn't pick easy numbers for x. Okay, all right, next one. Oh, give you time. Okay, all right, here we go. Now we want to write the partial fraction decomposition of 6x cubed plus 16x over the quantity x squared plus 3 squared. So denominator's already been factored for us as much as it can be, right? When we set this guy up, what's it going to look like? I like that. Does everyone see why he chose linear? Our bottom is quadratic, so we have to have an ax plus b over x squared plus 3. What else do we need? Good. We can't just include the squared term, that quantity squared, that binomial squared. We had to include the lesser one as well, the lesser factors. Okay. Everybody good so far? All right, so we're going to multiply by our greatest common, or our denominator, right, to clear the denominators. So the easy part is to say 6x cubed plus 16x will be equal to, if we're multiplying by the x squared plus 3 quantity squared, we cancel one and we'll have ax plus b times the other one. If we multiply by x squared plus 3x quantity squared, we just get cx plus d. Are there easy numbers to pick out this time? So what we're doing is I didn't show it, but we're going to take everybody times the x squared plus 3 quantity squared. So when we do that, denominator's gone. One of these denominators is gone, or one of the numerator, and then everything's gone here. Okay? Bless you. So what the net result of these is always that the denominator disappears in our complex fraction, but the lesser one has to still have one, and the one that had everything as well disappears. Okay? So far so good? All right, so the next part then says, if we can't find a good number to plug in, let's go ahead and FOIL things out. So I'll have an ax cubed. Then let's do the insides next, because we're going to write it in descending powers of x, so bx squared. Then the outsides, ax times 3. And then the last, 3b. Okay. This time we only have a single x squared and a single x cubed, but we need to put these two together. So if we take the GCF of those two, we'll take the x out, and we'll have 3a plus c. And then these two are our constants that have no x involved. And that's equal to 6x cubed. Do we have an x squared? Nope. We have a 16x. Do we have a constant? Nope. Okay. So we know that a will be equal to 6. We know that b is equal to 0. 3a plus c is 16. And 3b plus d equals 0. So if a is 6, what is 3 times 6 plus c equals 16 going to simplify to? -2. And 3b plus d equals 0, right? And b was 0, so 3 times 0 plus 0 equals 0, so we know d is 0 as well. So all that's left to do is rewrite our partial fraction. Okay? 6x cubed plus 16x over the quantity x squared plus 3 squared is equal to a x plus b, and b is 0, right, over x squared plus 3 plus c x plus d, d was 0 again, over x squared plus 3 quantity squared. What questions do you have on this slide? Okay. There's one last one, and it's not as hard as the other two. Okay, these are the toughest ones because we don't have easy numbers to plug in, right? Those quadratics make it difficult. Last example, the only reason I mentioned this one, oops, I'm sorry, is I think that most of you have forgotten how to factor difference of cubes or sums of cubes. Okay. Because this guy is I have no number, no constant, right? And these guys are the only ones that didn't have any x's with them. Yep, they have to equal your constant. The ones with x's have to equal your coefficient of x. The ones with x squareds have to equal the coefficient of x squareds, and the one with x cubed has to equal the coefficient. So b was 0. And I should have written that down. Should have written that in red. Right here. Okay. So all I said was I have one x squared and I have a x cubed, right? So I don't have to combine anybody. But these guys both have an x. So what's the greatest common factor of them? X, right? And what's left? Okay, so I just grouped them. Yep, exactly. These two don't have any other numbers, so we just put them together. Just writing everything in descending powers of x, and if there's a common factor, we take it out so we can see what that has to equal to. Okay? Other questions on this one? Didn't wait long enough. That just came from here. And I said, let's put our placeholders in. Yep, we were missing some descending powers of x, so I just put the placeholders there to make it obvious where they go with. Yes. Anytime that you see it's quadratic and we can't factor it further. Yep, if this had been x squared minus 4, we'd factor it into x minus 2, x plus 2, right? But when we see a sum of squares, we can't factor that. So then we have no other result but to use it. And when it's quadratic, then we have to put a linear above. Okay? Okay? X squared minus 3, same thing. We're not going to bother with the x plus the square root of 3, x minus the square root of 3, because they're not going to be nice numbers to try to plug in as zeros. Yep, yep. If it's factorable, factor it, but if it's not going to be integer factors, then we just keep going. Okay? Great questions. You feeling okay? All right, last example is not very tough, but I have a feeling that most of you have forgotten how to factor difference of cubes. Okay? This is of the pattern x cubed minus 1. And does anybody remember how to factor difference of cubes? Okay. Very good. Okay. So this is something you learned in Algebra 2, but it was probably a quick one-day type thing and you haven't necessarily mastered. Okay? The sum or difference of cubes follows this pattern. Oops, meant to have a build there. I thought I did. Okay? Why didn't it show up? So the sum or difference of cubes follows this pattern. If you have an a cubed minus b cubed, it will always be a minus b. You strip off the cubes, and then in the next parentheses you square the first, you multiply these two together and change the sign, and then you square the last, and the last one's always a positive. Right, not a space. Yep, it's supposed to be squared. B squared, yep. I'll shift the other one over. Yep, multiply them and change the sign. Okay, so if it was a cubed plus b cubed, it will be a plus b. We strip off the sign, the cubes, and then we square the first one, multiply them and change the sign, and we square the last one, always plus for the end. And when you get to calculus next year, Mr. Schmidt will say, I'm going to show you this once and you better remember it. Because by then he expects you to know it. You remember that? Yeah. And it's not something that comes up very often, so we tend to forget it, and then if someone reminds us, it's like, oh yeah, I got that. I remember doing those. Okay, so let's pick some cubes. Let's pick something other than a cubed and b cubed. What if it was x cubed, y cubed minus 27? Strip off the cubes, right? Same sign. Then what would we do? Yep, x squared, y squared. Change the sign, 3xy plus 9. And if you FOIL that out, or actually not FOIL because it's not just 4 parts, but if you distribute that out, multiply that out, you'll get your original. Okay? All right. So we've factored our difference of cubes. Okay? That means that we need what for our partial fractions? A over x minus 1. That's the easy one, right? Everyone understand why? Okay? And now we're back to what we've been doing. Okay? We just don't, like I said, don't remember necessarily how to factor difference or sums of cubes. So if we multiply everybody by the x cubed minus 1, those would go away. Okay, so I'm going to have a 5x squared plus 4x plus 6 equals, a is going to be multiplied by the x squared plus x plus 1. bx plus c will be multiplied by the x minus 1. Okay, now we do have an easy number that we could plug in, right? But we'll still have this mess to contend with, and so we're going to just go ahead and FOIL it out. So we'll have an ax squared, ax, a, and then bx squared minus bx plus cx minus c. Okay. A, b are our x squared terms, right? So x squared is times a plus b, right? What are our x terms? 3 of them, right? So we'll take an x out and we'll have a minus b plus c. And our constants, oops, a minus c. Okay, that's going to be equal to the 5x to the 5x squared plus 4x plus 6. You could put them in parentheses if you want to think of this as this whole thing is our constant term. Oh, I'm sorry. Yes, this one was supposed to be in parentheses. My fault. Okay. So a plus b has to be equal to what? And a minus b plus c has to be equal to, and a minus c has to be equal to, okay. So now we're up to systems of equations with 3 unknowns, right? Okay. So if a plus b equals 5, could we combine these two and eliminate a b? Okay. So we would get 2a plus c is 9. And if a minus c is 6, if we combine these guys, 3a equals 15. What's a? Okay, if a is 5, 5 minus what gets us 6? Negative 1. And if a is 5, 5 plus, or is equal to 5 plus what? Okay, so we're ready. Our final answer is this is equal to 5 over x minus 1 plus 0x, right, minus 1 over x squared plus x plus 1. It is tricky. It's kind of a puzzle, though. It's kind of fun. I think it's fun. I get to use all kinds of colors, right? Yeah. All right, questions on this one? So assignment's coming next, and it should be on your green sheet exactly as it is, right?